So this problem refers to a circuit that we saw earlier where the switch was thrown over to the battery and it was charging up the capacitor. Now the switch is thrown so that we're sealing off the battery. The battery is now disconnected and the current is going to flow in the opposite direction from the capacitor through the resistor. It's being discharged. So the question asks us to, after how many time constants is the charge on the capacitor 1/4 the initial value? So if we go to our equation for charge over as a function of time, that's our equation. Now I always get mixed up, is this charging or discharging? So at time 0, Q should equal Q max. So at time 0, this comes in, this is e to the 0, this is 1. Okay, so we're good. Now at time equals infinity, charge on the capacitor should be 0 because all of the charge is dissipated. So if I put infinity up there because of the negative there, that's going to give you 1 over infinity, which is 0. 0 times Q max is 0. So this is the right equation. So we need to find the time constant, how many multiples of the time constant it passed before Q equals 1/4 Q max. So 1/4 Q max, Q of t equals 1/4 Q max, and that equals Q max e to the negative t over tau, which is RC. Okay, so working with this side, if I divide each side by Q max, that cancels out. So you have 1/4 equals negative t over tau. Now I need to isolate t. We're solving for t. So I'm going to take the natural log of each side. Okay. So can't simplify that. This equals, the natural log is the inverse of the logarithmic exponential, so that gives us negative t over tau, or t equals negative tau times natural log of 1/4, and natural log, let's see, where's my natural log button? Oh, here it is. Natural log of 1 divided by 4 equals negative 1.38, but the negative there makes it positive 1.39 times tau. That's the answer to the question. So the next thing says how long passes until, I'm just going to draw it over here, until the energy is 1/4 of the maximum energy. Well, we know that the maximum energy, the steady state energy, the energy when fully charged, U, is equal to Q squared over 2C. So we can say that U as some function of time is equal to Q of T squared over 2C. We can also say that Q of T equals Q max e to the negative t over tau. This is all squared because that's Q of T over 2C. Or U of T equals Q max over 2C, Q max squared over 2C, e to the negative 2t over tau, because you're squaring this exponential, so that becomes negative 2t tau. And this is just U max. When the charge is maximum, we've reached U max. Okay, so we need to find t when U of t equals 1/4 U of max. So that gives us 1/4 equals, 1/4 U max. That is what U of t equals. equals U max, that's what this is, e to the negative 2t over tau. So the U max cancels out, and now we're going about solving the problem just like we did before. I'll move over here. So if I take the natural log of each side, where the natural log undoes this logarithmic exponential, so that gives us negative 2t over tau. And then, not tau, solving for t gives me negative 1/2 natural log of 1/4 tau. And when you throw this in your calculator, that gives you 0.693 tau. So 0.693 times the time constant puts us at that energy.